Right folks, so I've had another Saturday working on the off-grid solar system. Just been wiring up the generators, so the first generator control, the cable goes all the way back to the back shed. I've got the switch wire which will turn it on and off when the voltage drops. So we're getting there, we're getting ready to fire it up. I just need to finish the battery cupboard and get the batteries in here. But something that came up on the last video, somebody thought I was going to overcharge my batteries and blow my batteries up by using the grid-tied inverter working with the Victron. And to a certain extent, their concerns are right. That will keep pushing power into the batteries. You know, there's no, it's not like one of these MPPT solar charge controllers where they drop down. But there's two kind of trains of thought and two ways we're thinking about that. First of all, we're using a Morningstar TriStar charge controller on diversion mode when the batteries hit a preset voltage. So like when they hit 61 volts, that will chuck 3 kilowatt of power into some wire wound resistors. Now I've found a bit of Unistrut, so I'm going to bolt the Unistrut to the shed roof to the purlins, and I'm going to put the wire wound resistors in the middle of that, so there's no risk of heat, no fire. We're not going to set nothing on fire. So we'll have 3 kilowatt of resistors on that as a fail-safe if everything else goes wrong. But also what we're going to use is we're going to use a relay driver with preset voltages. So we'll basically have 4 relays where we can send the excess power when we hit like a voltage like 59 volts. The relay driver through a Cat5, like a telephone cable, will run relays in the caravan. The first one will turn the immersion heater on. The immersion heater will be a standard 240 volt immersion heater with a thermostat, so when either there's too much power for that to get rid of, or when the immersion heater turns off, then it will turn on relay 2, which will be a storage heater. Then we'll have relay 3, which will be another storage heater, and relay 4 I'm going to leave spare for one of the emergency backup generators. If the one of the inverters goes down and doesn't turn the generator on, we'll have another generator that it'll turn on to protect the low voltage on the batteries. But you know, we've got that wired up. I've been running cables all day today. So yeah, basically the idea of using the grid-tied inverter is so we're not losing so much power. A grid-tied inverter, you get about 5% losses. Using a charge controller like this and putting everything into the battery first and then having to pull it back out of the battery when you use it, you get about 30% losses from the solar panels to the plug socket. I've had somebody arguing with me on one of the YouTube videos that I'm wrong. You know, yeah, I'm not in the business of arguing. Think what you think. This is the way I'm doing it. There's a few really good guys on Facebook that are doing this sort of system using grid-tied inverters. One of them's Mingu Moore, I think his name is. He actually phoned me the other night and talked me through how to do like the relay drivers and everything, and it was quite interesting because this is information you can't get anywhere, information that nobody will tell you. Another guy, Paul Camille, he commented on the post on Facebook and gave me some advice, and he put me in the direction of Hugh Piggott's website, which is, I think it's Scarraig Wind. I'll try and put a link in the description of this. So on Hugh Piggott's website there is basic instructions, basically how to work these TriStar charge controllers, these PWMs, on diversion mode. Again, it's something there's just not a lot of information out there about, and if you go and buy a solar system off the shelf off one of these suppliers that's going to charge you 20-30 grand, all that you're really going to do is get like a combined charger, inverter and one battery. That's, people keep coming to me and messaging me on Facebook and saying, look, can you come and look at my solar system, it doesn't work, this, that and the other. And there's a reason it doesn't work. You know, a lot of people are having systems installed by companies that are just used to putting solar panels on domestic dwellings where they've got grid-tied electric. A system like this, because we're using flooded lead acid batteries, and there's a reason we're using them, I've explained it before, we need quite a lot of solar, and any off-grid system, you're not going to live off-grid with just 3 kilowatt of solar panels. It'll be fine 6 months of the year, maybe 8 months of the year, but in the winter, solar does very little. And unless your system is rigged up properly with a diesel generator that turns on and off, you're just going to run out of power. And I've seen it around here, there's quite a few people that are off-grid, and several people have contacted me. It comes to October and they've got no power, and the batteries are getting damaged, and they're using a separate charger, having to run a generator, turn it off and on and off in the middle of the night, and they're just struggling to live off grid. And I'm going to watch what I'm saying, because I know one place went up for sale recently for a similar reason to this, but they're just struggling just because the systems aren't set up right. So, you know, there's a lot of evolution gone into this system. It doesn't look the best, you know, we're working on a limited budget, a lot of it's second-hand equipment, but I've been off-grid for 20 years. We've been off-grid at this property for 13 years. You know, we're on our 3rd solar system, not because they were crap or because they're broken, but just because as things move on, you need a bigger system, you learn, you know, I'm learning every day. I do these videos on YouTube not to be arrogant and not to show off. Some people think I'm being arrogant when I put a video out. I'm not. I'm just showing you what I'm doing, because hopefully other people that are trying to be off-grid will learn by what I'm doing, the mistakes I'm making, and just me, you know, showing you how we're setting things up. So the idea is, like, we're going to have about 16 kilowatt of solar here. We will probably have a wind turbine at some point in the future. I'm not rushing to do that because it's quite expensive, and I'm just trying to see how far we can get with the solar. Another comment, somebody thought we'd got grid electric because I use these cutouts in each building. I use these cutouts, and the people have said, you don't need them, why are you using them? Well, if you look in your house, your normal domestic dwelling, you've got a primary form of protection, so that's your primary form of protection, 100 amp fuse. You can actually put a 60 or an 80 amp fuse in there for a smaller system. And then you've got a 6-way earth block there to put your earth rod into, your earth coming from your inverter, your earth from the structural steel, your earth from the water bonding. These were about 12 quid off eBay just now. I don't know where they're coming from, they're obviously used. But you know, as a primary form of protection, if everything else goes wrong, if your RCDs don't trip, this is your primary form of protection. And I just don't understand why people would wire a building, a house, a caravan up without using a primary form of protection. So this is what I do. I fit a main cutout in each building. I then fit an electric meter. Again, people are asking why we're using electric meters. Well, we're not buying the electric. So I bought that off eBay, I think that was £8. So I put an electric meter in each building on each system, just so we can monitor what we're using, or what the grid tied inverter on the other shed is pushing back into our system. If you don't monitor things, you don't know what you need, and this is a project. So I'm trying to work out if we can get through the next year without turning the diesel generator on. That's my main aim, is to get the system up and running by about July properly, functioning with the generators turned on. The generators have got hour meters on them. We'll also monitor the diesel usage. But we really want to try and get through next winter without using the diesel generator. And if we do use the diesel generator, I need to know how many hours a day it's running and how much diesel we're using. Our diesel usage hasn't been bad over the last few years. It's been about £500 a year, but the diesel's not even half the cost. Just explain that better. You know, people worry about having to buy diesel. Well, it's not the diesel that costs money. It's the cost of buying and servicing generators. Like, generators are not cheap, and a lot of people don't know how to fix generators. I'm not great at fixing a generator. These shitty little Hyundais I can fix. I've had a bash at fixing some listers. I'm not great at fixing lister generators, I'll be honest. So, you know, yeah, 500 quid a year in diesel. The generators, you know, to buy them, to run them, you know, depreciation is probably another 500, so we're probably at £1,000 a year. And if I can get rid of that £1,000, this system's a lot more sustainable. So just to finish off, I'm just going to explain to anybody that doesn't know what these wire wound resistors are. Now this is our very, very old solar system. Looks bad, doesn't it? But this was a 12 volt system. We decommissioned this about 7 years ago. It was either 2016 or 2017. We stopped using this system. We went onto the new 24 volt system that we're on now. And this is just a very, very old charge controller. I've actually, literally about a month ago, got rid of the solar panels that were on this roof. So there was a wind turbine and solar panels coming into this. And these wire wound resistors are our dump load, or were our dump load, just to get rid of heat. Now I know they shouldn't be screwed onto wood. It's a really bad idea, but they were working, and the system worked for years. It worked for, gosh, 6-7 years this system worked for. And it worked, it did its job. We got rid of the heat, you know, the batteries didn't overcharge. We only once had a problem with the system, and that was when we'd stopped using it and we were using the new system, and we just only had one battery on this, and we were using it for lighting just down these old stables before we built the new shed, and I had a battery explode. Lead acid battery, and it's just one of these sealed leisure batteries that you can't top up with water, and it exploded, you know. But that's the only issue we ever had.